Alright, so now we have to use this function to answer the following questions. So it says, which of the following is an x-intercept on the graph? So an x-intercept is basically where the function equals 0. So we set the numerator equal to 0. This would be x times 2x minus 3 equals 0. And so since x is on the outside, it's being multiplied, we can divide x. And we're left with 2x minus 3 equals 0. Move the 3 over, we get 2x equals 3, and x will equal 3 halves. And so if x equals 3 halves and 0, so we'll get the answer to this will be B. For number 4, it asks which of the following are vertical asymptotes on the graph. And so vertical asymptotes are going to be where the denominator equals 0. So we're looking at x plus 4 and x plus 1. And so that would be where x equals negative 4 and negative 1. So which of the following is the horizontal asymptote on the graph? And so for this, we do have to expand this out. So we'll have 2x squared minus 3x over x squared plus 5x plus 4. And so with this, for horizontal, either the denominator has the higher power or the denominator and the numerator are the same power. So in this case, we have x squared in the denominator and 2x squared in the numerator. And so when it's equal like that, where the powers are the same and the numerator and the denominator, then we just take the ratio of that. So we'll have 2x squared over just an x squared. So that's going to be 2. So our horizontal asymptote will be at y equals 2. If this was a cubed, if for example instead of 2x squared this was an x to the third, then the horizontal asymptote is always going to be 0. Okay, so number 6, these are all more definitions, so I'll let you guys look these up. You can use Google or look at your textbook, but this is more so for you to memorize definitions. Alright, number 7, we're going to complete the diagram and graph the function below. We're given the number line again. So the first thing is we have this big function here, but the first step is always to simplify. So as you can see, we already have an x minus 5 in the numerator and the denominator. So the next thing we can do is factor this out and see if any other terms cancel out. So we'll have x plus 4 times x minus 1. And this factors out to x minus 7 times x plus 1. So we can see that no other terms will cancel out here. But what we can do is find the vertical asymptotes. And then also it's an easier way to find out where y equals 0. Okay, so it looks like we'll have a vertical asymptote at x equals 7. And at x equals negative 1. The next thing we can do is solve where our y's are going to equal 0. We can take this, the numerator x plus 4 and x minus 1, and we'll see that y will equal 0 at x equals negative 4. We'll just plot a point there. And at x equals 1, we'll plot a point there. So that's 1, 0. And that's negative 4, 0. So we can do, we'll plot out also on this number line here our negative 4 and our 1. And then we can also put our negative 1 here just to get our sign changes. So anywhere that the function is less than 4, we can take f of negative 5. And we can plug that to our function here. Basically, we're going to get a negative term for this, then another negative term here, and we're going to have a negative term in the denominator and another negative term. So we're basically dividing a positive by a positive, right? So all the y values on the left side of 4 are going to be positive, and they're heading to 0. And then from negative 4 and negative 1, we can test out another value. Let's say f is negative 2. F of negative 2, and so we'll have a positive times negative over a negative times negative. And so this will all come out to negative. And it'll go down like that, never actually having a y value at x equals negative 1. Then we can test between negative 1 and 1, so we can do f of 0. So then we can take f of 0, and that will be between negative 1 and 1. And that will be 4 times negative 1 over negative 7 times 1. And that gives us a negative 4 over negative 7, which is a positive 4 over 7. So it looks like it's coming down this way. So it's coming down this way, and then between negative 1 and 1, this is positive. And then we can test any values greater than 1. We'll test 2, and that will give us a positive times a positive over negative times positive, and we'll get that this whole thing is negative. So the graph will come back down like that. And so for the rest of this graph, you can plug in higher values greater than 7, but the graph will probably look more or less like this. Okay, so B asks for the coordinate pair of the y-intercept. So we can do that by taking f of 0, and we actually found that out to be 4/7 over here. So this point here is 0, 4/7. Then it asks for the pair of any zeros, and we found those already. We have negative 4, 0, and 1, 0. Then it says coordinate pair of any holes. We have none. Equation of any vertical asymptotes. So that's at x equals negative 1 and x equals 7. Okay, so next we're asked for the equation of any horizontal asymptote. So this is where we can even fix our answer up, because we didn't really think of this. But since we have our equation of x plus 4 times x minus 1 over x minus 7 times x plus 1 times x plus 1. If we expand these out further, we'll get an x squared in the numerator and an x squared in the denominator. So our ratio would be 1, since the coefficients for both of these would be 1. So we'll actually have a vertical asymptote at y equals 1. So we can also mark that here, something like that, at y equals 1. And so you see that this part of the graph will always continue on and never actually equal 1. And so we can fix up this part of our graph. We'll get rid of this, and our graph will actually go out like this, never having a value at y equals 1. So since we had a horizontal asymptote, there wouldn't be any oblique asymptotes.